Okay, my friends, so here's the results we just got. We spun 40 pennies. We got 16 total heads. That was, it says your class. I use this spreadsheet also when I do my in-person class experiment, which we do this experiment each term. This is why I have so much data from this. 40% heads, okay, with our margin of error of 15%. So you can take a look over here at our confidence interval. It goes from 25% up to 55%. Let's compare this interval to the first one we got when I spun 20 coins and only got 5 heads. 20 coins, 5 heads. Okay, when you do that, look at that interval. That's the interval we got before, 6% up to 44%. That interval was evidence that spinning a coin was different than flipping a coin because 50% is over here kind of floating outside of the interval. When we increase the number of spins to 40 and change the number of heads we got to a total of 16, that new interval, since it crosses the 50%, does not show a difference between spinning and flipping. But some of you might be thinking, yeah, Sean, but still, both 5 out of 20 and 16 out of 40 are less than 50. Yeah, it's not significant, but maybe there's something there we just haven't seen yet. Now, what I've actually got in this other tab over here are the historical results that I've been collecting ever since I started doing this. It looks like I did it way back in whatever early means, but the first dated one I have is fall of 2006. Man, that's almost 20 years ago. So then we had 300 spins. We got 117 heads. In 07, we did 330. I had 140. I sat in for Donna's class that day. This was a conference I attended. I made all the attendees of my talk spin pennies and collected all the data here. Okay? Now, it's a little hard to kind of see the data in this form, so what I'm going to recommend that we do is we're going to get some sums here. So the first thing I'm going to do is I'm going to hit that column right there, and it's going to tell me that, oh my goodness, in all the time I have done this experiment, I have had students and myself spin 23,426 spins. How many heads have we gotten in all that time? We've gotten 10,288 heads in all that time. Okay, so let's take those numbers. Let's learn how to use a new tool that I've built for you. It's over in Canvas in week 2. Let's go take a look. Okay, my friends, so now we're in Canvas. I tried to put this tool over here in this sidebar, but my goodness, Canvas is really weird about putting externally linked files there. So I put it in week 2 instead. If you look at week 2, at the very bottom of week 2, I think I referenced this back in week 2, the Excel calculator. Crack this thing open. You may have already used it. I hope you did anyway. It's probably better to download it. It doesn't seem to behave very well in Canvas. So make sure you've got Excel on your machine, and let's crack this thing open. Okay, so here she is. We're going to enable editing because we want to be able to change things in it. I guess it's got a macro in it or two. We're going to go ahead and hit enable content. Okay, trust me, I'm not putting computer viruses in these spreadsheets. All righty, here we go. Confidence interval for one proportion. It's the second tab over right here. I'll zoom in so we can see it better. So all you've got to do, my dear friends, and this takes care of all the heavy lifting of all the silly arithmetic where mistakes can often be made in calculating these margins of error. You just got to put in your X value, which is the number of successes, the N value, which is the number of trials you ran, and what confidence you'd like. Now, I've got it set at 95%, which I think is pretty much what I'm always going to ask you to do, but in case you ever need to change it, you can. In case you forget what these little letters mean, you can hover over the cells and it'll tell you. So, for example, let's just run the first 2 examples we did. We got 5 heads out of 20 trials, and these numbers might be familiar to you. 25%, that's the p-hat, that's a sample proportion, plus or minus that 19% margin of error. So that's calculated for you. The formula's up here in this cell up here. And then here are the left and right bounds. LCL stands for lower confidence limit. That's the technical term for it. I learned that from an engineer. And UCL is the upper confidence limit. Those are the left and right bounds of the confidence interval. And these numbers also look familiar to you. 6% to 44%. When me and Wendy added our trials in, we then had 16 results out of, what was it, 40? Look at that. 40 plus or minus 15, which means it's 25 up to 55. And now, drum roll please, we have 10,288 heads. Out of, don't ignore those number errors. It's pissed off because the sample size is too small. out of 23,426 total spins. Aha! Look at that! Oh my goodness. P hat is about 44%. The margin of error is less than 1%. In fact, if we go back and look at historical data, check this out. This is really cool. Here are the same values you saw earlier from 2006 all the way down to the one I just did just now with Wendy. And here are the corresponding confidence intervals for each right here. So this is each class's confidence interval. Notice a couple things. Some of the confidence intervals cross the 50% line. This is the 50% line right here. So if you scroll down, you see quite a few of them do. Quite a few of them do. But a lot more don't. And I want to stop right here and mention this. As statisticians, you don't often get this kind of meta-analysis. We talked about this before with the confidence quiz from last week. This is 20 years of quote-unquote research on penny spins, right? I get to look at all this and say, oh yeah, something is definitely going on. Even though sometimes I get these crazy wide confidence intervals. And they're only wide because the sample sizes are very small. I'm going to have you analyze. You may have noticed this looking at this picture. As the sample sizes get larger, the confidence intervals get narrower. Smaller the sample, wider the interval. Larger the sample, narrower the interval. Hopefully you're seeing that as you see. And then, of course, the big one right here is this puppy dog. This one here, which was based on, let me get those numbers again. We had 23,426 spins out of 10,288 heads. Look at that. Margin of error of 1%, 44% P hat. Look how narrow that interval is. Okay, I think we're done with coin spins for right now. I think we get the point. We learned a couple good things here. Let's go back and look at that data from my distracted driving study that I did.